Hey, good morning, everyone, and welcome to our EMEA Forum 2020 demo. So if you've not seen us before, we are a team that normally come along in the UK forums anyway, and we run demos. So last year we were live, we were on stage, we ran a great demo, we ran a game. We did lots of cool things last year. This year it's all virtual, but we're live, right? So we're doing this live now. And you're going to be joining in because we're going to be playing games in the middle of this. So it's going to be great. So we've got 30 minutes to show you some awesome stuff, and I've got some great people to help me. So I'd like to just mention Erin Murphy. Give us a wave, Erin. So Erin's going to be talking a bit about our infrastructure. Ian Uth Lawson is going to be talking about, he's been an operator for a long time. He's going to be talking about Advanced Cluster Manager. That's what we're going to be showing you. And finally, we've got Mark Roberts. He's an app dev guy. He's going to be talking about some of the app dev pieces that we're going to be showing you in our demo. So let's get on. So we've got 30 minutes. We're going to be showing you how to build, but we're going to be showing you a global architecture. We're going to be going from remote edge through to private data center to multiple public clouds. We're going to be really showing you some open hybrid cloud. Now for me, that's something that's been really hard to do, is do open hybrid cloud across multiple geos, across multiple public clouds. And managing the applications across multiple geos and multiple public clouds has been really difficult in the past. But we're going to show you today it's super easy. We've got some tools and we've got some things that we're doing in the application side that's going to make it super easy and for you to be able to do. Okay, let's take a step back. So back in 2015, so Red Hat were the first company to bring enterprise Kubernetes to the market. If we look at how we were building clusters at that time, we were building kind of large clusters. We were building large multi-tenant, multi-people, multi-project clusters. And that's cool. We can still do that, and that's still a great use case for OpenShift. We've got lots of customers who are running secure multi-tenanted single cluster OpenShift. But we've got some different things coming into the industry now that's making us try to reevaluate how we're running our Kubernetes OpenShift clusters. So we're looking at things like edge requirements. We're looking at things like 5G and globally distributed data for global organizations. Some of these requirements just don't fit having a single cluster. So you may have things like different data requirements for different geographies, but we might still have the same applications that spread across those geographies. So the things that we're looking at, so Kubernetes, we know Kubernetes is growing. Kubernetes is growing enormously, which means OpenShift is growing and growing enormously. Multi-cloud and multi-cluster is a real thing, right? And it's a real thing now that organizations are trying to solve. Managing multi-cloud and multi-cluster is hard. So that's what we're going to be showing you. We're going to be talking through some of the infrastructure components to show you some of this stuff. And we're going to be showing you a game. And let's have a look at the game. So here's a URL that you're going to be hitting, okay? So we're going to be playing a game. It's called Guess That Price. So the price is right. Or Leslie Crowther is going to come and show you the game that we're going to be playing. If you log on to this URL, it's in the agenda, it's in the sidebar there. You'll see the URL there. Log on to that game either on your phone or on a browser. You'll go into a lobby right now because we're not starting the game yet. We'll start the game in a minute. What we're going to be doing is talking to a couple of our techies here just to get a feel of some of the things we're trying to solve in that game. So before we go into the game, let me tell you a story about some of the infrastructure that we built. And we're going to be using a bank as an example of this. So we have a global bank that originated in East Coast USA. That global bank started as a local North American bank, and it quickly became a global bank. And it started realizing that, okay, to become a global bank, I need hubs across the globe. I need to go to London. I need to go to Frankfurt. But I've got specific European data restrictions of running in EMEA in Frankfurt. So I need different data centers. I need different clusters. So the bank quickly grew lots of different clusters with lots of different data requirements across the globe. Now that's the hard thing, right? The applications are similar across all of these distributed clusters, but they need to be separate. They need to be geographically separate, and they need to be closer to their customers. Now, I'm not an infrastructure guy. I'm an app dev guy, but I've got some smart infrastructure people to talk to on here just to tell us about some of the components that we've got in this architecture. So I'm going to talk to Erin. Erin's a really smart cookie. She's an infrastructure girl. So Erin, can you tell me about some of the infrastructure that we've put together to represent this in our game?
Hi, yeah, Graham. So today we have a relatively small size cluster of clusters running throughout Europe, with our admin HQ and our London Edge clusters being hosted on AWS in London, our other Edge clusters being hosted on Azure and IBM Cloud, both in Paris and Frankfurt. And each of these clusters hosts local content for each of the different countries, but also hosts some of the distributed services which make up part of the game.
Awesome. So we've got 3 clusters plus a management cluster. Okay, so answer me this. Why not one large cluster?
So first of all, let's touch on that point you brought up earlier about having different laws and regulations in countries. When you run a single cluster, you are restricted in what policies you can apply to the nodes within that cluster. So you would have to build the same across the globe, which just wouldn't work with the legal loopholes you'd have to jump through. Not to mention, when you start building large single clusters, you start to introduce a lot of latency. If you were to run a global bank and start serving some smaller regions, your entire infrastructure would be limited by the speed and the power of the node in the slowest region. Plus, when you start to scale with multiple nodes, you become less agile and you have more battles to fight when it comes to scaling up or down.
Okay, excellent. So if that's kind of solving some of the problems with one large cluster, what's the benefits of having multiple clusters? Is there any benefits?
Absolutely. So having multiple clusters means that your clusters are going to be smaller, and that means they are relatively quick and easy to build. And because of that, you're able to tear them down fairly easily. When it comes to your boom periods where you have a massive influx of traffic, you can scale up on demand. And when that traffic disappears again, you can scale down without expending any excess money on that infrastructure. Plus, there's the age-old adage of not putting all your eggs in one basket. If you build a single cluster that stretches across the globe, if that one cluster was to fail, there's no mechanism to really recover from that failover. So when you build with multiple clusters, you're able to transfer your workloads to different clusters, or even rebuild a cluster to transfer your workloads to. And as we always say in the industry, we always want to try and scale horizontally more than we can vertically.
Awesome. So if I look at what's on the screen now, so I'm seeing multiple clusters, multiple clouds, lots of edge things connected to those multiple clusters. For me, this looks difficult, right? So for me, it looks like we're rebuilding things all of the time, replatforming things onto different clouds. That just looks a mess. Is that right?
It might appear that way, but it's really not. So when you build more clusters, you're not actually introducing more complexity, especially when it comes to being across different clouds. As the clusters are more or less the same, with only policies being applied to differentiate them, they're essentially the same but different, which means there's less to go wrong, and should something go wrong, it's a lot easier to fix because you have that common blueprint. Now, Advanced Cluster Manager also makes the building and management of multiple OpenShift clusters even easier, with a single point of administration, operation, provisioning, and infrastructure and application lifecycle management.
Wow. Okay, brilliant. Thank you very much, Erin. So you're telling me it's easy to do, it's easy to manage. I want to see that, and I guess you want to see that as well. So I'm going to bring in Uth. Uth has been an operator for many years. He loves Advanced Cluster Manager because of the ease that it gives you with managing clusters. Uth, tell me about Advanced Cluster Manager. I know you're excited about it.
Yeah, hi Graham. Yeah, absolutely. I'm very excited about ACM because it is the missing piece in the puzzle. as Erin said, it's become much easier to actually install OpenShift and install Kubernetes. But it's still a problem if you've got it in multiple places. If you want to install, let's say, 5, 6, 10, 20, 50 servers, it's a lot of overhead. And what we've done with ACM is we've produced basically a single point of control over all the problem space you've got in actually managing those multiple clusters. But I'm not going to talk about it. I'm going to show you it, assuming that the demo gods are going to be nice to me. So what we've got here, if you can see, is the actual front page of the ACM. And this actually reflects the design methodology we had for Advanced Cluster Manager. It covers 4 major units. The first thing is the end-to-end visibility, and that's the ability to see what's going on in your supercluster at any point in time. The second thing is cluster lifecycle, and that's all the components and tools that allow you to manage the clusters, to create the clusters, to maintain the clusters, to take the clusters offline and do those kind of stuff with it. But clusters are clusters. The applications are what make these systems. And we've also got now the application lifecycle controls within the Advanced Cluster Management. And what that allowed you to do is to actually manage the placement of Kubernetes resources across your cluster. So you can define your application in terms of Kubernetes resources, and then using a set of rules, you can actually deploy them to target clusters within your supercluster. And the fourth component is one of the most important. That's the governance, risk, and compliance. And that allows you to define rules for the compliance of your clusters. And the ACM will actually enforce those and take the clusters offline if they're not being compliant. So the first thing I want to show you very quickly is if we go to the overview, you'll see, as we described in the overview of the actual demo system we're using, I'm currently running 4 clusters. I've got 2 in AWS, 1 in Azure, and 1 in IBM. So I've got a single control point over multiple clouds. Now, if we go and look at the clusters themselves, you'll see something very interesting. Running 4 clusters, each of the clusters has a set of labels that's metadata that's actually owned and run by ACM itself. And we use that metadata to control the behavior of those clusters. And this is where the important thing comes in around the application side. Because if we examine, for example, Frankfurt, if you can see the labels, I've got a type equals edge. And currently, I've got 3 clusters in my supercluster defined with type equals edge. Now, if we go and look at the application side of it from an application managed perspective, what I've done is I've created a simple application. It's a simple web server. And I've actually got that deployed on 3 clusters. It's using the label on the clusters to define where the application is landing. And if we click on the application itself, you'll see the actual definition of the topology. If I click on the subscription, you'll see it's actually in 3. The application workloads are made up of 3 things. There's a channel which contains all the Kubernetes resources that have to be pushed to the target cluster. There's a subscription that says which clusters it goes to, and that uses the rules placements. And the placement rules themselves are the actual rules that tell the application where to land. And I'm going to show you in action, because if we go back to the clusters themselves, what I'm going to do is I'm going to actually change the labels on the London Edge cluster, and I'm going to remove the type equals edge. So that instantly has taken it offline from a perspective of being an edge cluster. If we now go back to the actual application and look at it, you'll see the subscription is now only running on 2 managed clusters. It says 3 managed clusters because it's actually tidying itself up. It's removing it from that cluster. So what it's done is it's actually taken that application away from the cluster that doesn't have that rule component in it. And that makes it incredibly good. You can see now it's dropped to 2 managed clusters. And if we actually look at the application itself and look at the subscription, you'll now see it's only running on Frankfurt and Paris. So you've got the ability to control where your applications are landing. Now, I know this is a simple application, and our demo application is much more complicated than that. Can you explain what that's about then, please, Graham?
Yeah, definitely. So thank you, Ruth. I like it as well. I love Red Hat Advanced Cluster Manager. It's, the thing for me is you can build clusters from within this tool. You can build brand new clusters. You can attach clusters. You can manage clusters. So I kind of see where you're coming from, Ruth. I love this as well. So we're ready for the game. Yeah, let's get on to the game. So if I go to the next slide, you will see that game URL again. Here it is. So guess that price. So get onto the game. go to that URL. I'll share my screen because I'm going to go onto the game as well. And I'll tell you about the game. So let me share my screen. Okay. It's called Guess That Price. Hopefully you can all see my screen. So we're in the lobby at the moment. I'm going to get Pat. Pat, start the game. Start the game, Pat. There we go. So our game is, you've got to guess the price of stuff from our cool store. It's as simple as that, right? Once you guess the price, you will get points. So I've got an example here. We're starting off with an easy one. So what's $1 worth? What's the price of $1? I'd like to pay a cent for it, but I think it's going to be worth $1. So I'm just going to drag. There you go. Just going to drag the numbers into the spaces to guess the price. So there you go. Let me do another one. So what's the price of this t-shirt? I reckon it's going to be $8.55. I might have done this before, actually, so I know the price. Here we go, $8.55. And every time I get the price right, I get some points. Every time I make a wrong guess, I lose some points. So let's get going. Start getting points, getting prices up there. If you look at the top of the screen, you'll see you've got a name. I'm called Bald Roarer. Brilliant. I'm looking at the Frankfurt Edge IBM. So my browser is connected to the Frankfurt cluster, and I'm connected to the Frankfurt Edge. And on to the left of there, it shows me my score. So let me see if I can just get another. There you go. Is it $5 now? It's going to be $9 for this cup. Wow, $8.80. Now I'm losing points every time I get a wrong guess, but I'm gaining points when I get the price right. If I ever get the price right. 59 cents. Okay. There you go. I've got it right. I've done $65. Okay, so there's the game. You're all connected. So you're all on mobile devices connected through to one of those clusters that Erin was showing you. Now, every time we make a guess and get some points, we've got a leaderboard to show you who's getting the most points. So let's have a look at the leaderboard. There's our leaderboard. Stump Bard is currently at the top of the leaderboard. So that's excellent. So we've still got Fantasy Throat and Fate Player in there. So what's happening in our game is our edge clusters are sending data through to clusters that are sitting and collecting and aggregating all of this data. So that's our game. We're going to talk a little bit about the game in a second, but have another couple of guesses. So my bag is $95. No, $93. Whatever. Let's pause the game and have a look at the application infrastructure. Pat, can you pause the game, please? Brilliant. Go on, Pat, pause the game. Yay. Okay, so we're paused. You've all paused. So that's important because we're going to be talking about that. Let's just head back to our slides because we're going to talk about some of the application architecture and what we've done to make this game available to you from multiple clusters. So remember this, right? In our infrastructure, multiple clusters, multiple geos, multiple clouds. Now, that's really hard from an infrastructure perspective. It's also hard from an app perspective. So distributed apps are really hard. And once you distribute them across clusters and across geos, it becomes really hard. Okay, I've got Mark. So Mark Roberts is our app dev guy. He's going to talk about some of the application infrastructure and architecture that we put together. Mark, tell us. Show us the infrastructure.
Okay, thank you, Graham. So let's introduce the application architecture and see what Red Hat technology is being used to create the game that you've just been playing. Now, I'm sure that you will see parallels to characteristics that you need to deliver in your own applications. So we'll start with the Paris a cluster located on the Paris location. And the application here has a browser-based mobile client that uses a WebSocket to interact with a Node.js application that manages the game running on that cluster. Now we have a Quarkus application that's used to manage your interaction with the game as you play. This shows an example of different runtimes being used for different purposes within a microservice-based application. And by scaling the Node.js and the Quarkus microservices, it's possible to accommodate many thousands of users on each cluster. Now, player interaction with the game needs to be sent to a headquarters application that will aggregate the scores and produce the leaderboard that Graham just showed to you. And for this, the Quarkus application uses an API for AMQ streams to post messages onto a Kafka topic. Using Kafka ensures that the communication to the headquarters does not become a bottleneck and all player data is securely delivered. Now, overall game status also needs to be shared across multiple locations that are hosting the game, such that each remote location is synchronized. And this status information is held within the distributed data store Red Hat DataGrid. So when you hear requests to start the game or pause the game, DataGrid will be responsible for delivering that information to all the clusters simultaneously. So this completes the view of the application for a single location. We have runtimes on the left delivering the application functionality, and we have different mechanisms for information distribution and sharing on the right. Now at the headquarters cluster, we have an application running to aggregate the scores, producing the leaderboard of the top 10 players. Now in this application, we have a receiving Kafka topic delivered by AMQ Streams. And to support the distributed nature of the clusters, we use MirrorMaker to replicate the stream topics so that each cluster has a local queue from which it takes messages. So we now show the addition of a new cluster in Frankfurt to provide an additional instance of the application. And depending on your requirements, this could be to distribute the workload for performance reasons, or it may be for reasons of disaster recovery, or perhaps for data sovereignty. So this raises a question of application management and deployment. How can I be confident that I have the exact same version of the application operating in the exact same manner in each location? And this question doesn't just apply to the versions of the application runtimes. It also relates to a myriad of properties and resources that are used by the application. All of these parameters need to be managed and coordinated across the multiple clusters. Now, the application runtimes and the supporting Kubernetes resources are all managed by the advanced cluster management solution described earlier, and that removes the effort of application management across the clusters. Now we can choose to place our clusters in Paris, Dubai, Madrid, and other locations, which is fantastic from a runtime application perspective and for supporting local customers. The application architecture and the messaging and data sharing mechanisms will allow the application to scale such that we can confidently meet the demands of the organization. As the infrastructure and the applications grow to support the business, how do we scale the management at the different locations? We have an infrastructure requirements that are clusters to create and manage, and we have an application requirement that are applications to manage, monitor, and update at all of these locations. And both of these requirements are addressed by advanced cluster management, enabling teams to create and deploy the applications that support the business without the costly proliferation of local teams to support and manage the environments. Graham.
Brilliant. Thank you very much, Mark. That was, so this is my stuff, right? I love application architectures. We've seen how we've got multiple clusters. We've got your devices are connecting to those clusters. Those devices are sending data into the cluster, which is being replicated to our admin cluster using Kafka Streams with our AMQ product, right? So we've got that. We've got the data being passed across all of the clusters. One of the cool things is we're sharing some of that, all of the game status and your player status is being shared across all the clusters using a distributed cache with our JBoss Red Hat data cache, DataGrid. This stuff's really cool. I've got Ian who wants to talk about some more of the Red Hat Advanced Cluster Manager pieces. There's tons of stuff in there, but Ian, tell me a little bit more about that, and then we'll go back to the game.
Yeah, hi again, Graham. Yeah, what I want to talk about very, very quickly and give a quick demonstration of, because we've mentioned how easy it is to add a cluster, but we haven't shown you. So what I'd like to do, again, assuming that the demo gods don't want to kill me today, is actually show you how easy it is. So I assume now you can see my screen again. We're on the clusters, and we've got the 4 clusters running. If you remember, I took the label off of the London cluster to take it off the Edge one. And I'm going to add another cluster in. Now, there are 2 ways you can do this. If we go to the Add Cluster button, we can create a cluster. Now, by creating a cluster, what we do is actually talk to the remote cloud we want to create the cluster on, and OpenShift and the ACM system will build the cluster for you. Now, unfortunately, I can't do that because it takes 40 minutes and my credit card is currently maxed out because, you know, what else is there to do during lockdown? So what I'm going to do is import an existing cluster. In order to do that, I simply have to give it a name, and we're going to create it in Dublin. I've got it already running on Azure in Dublin. I'm going to pick Azure. On the environment side, I'm going to make it a production one, so it's the same as the other ones. And I'm going to give it the label type equals edge when I actually import it. I hit generate command, and what that does is it generates a command I have to run on the remote cluster. The remote cluster then will effectively phone home and log itself into the ACM system. So on another window, what I will do is actually run that command on the actual cluster that's running in Dublin. And that's actually been executed. And what I will see now is if I go back to the clusters, you'll see that Dublin is pending an import. It takes around about 2 to 3 minutes. And I say we're running out of time. I'll leave the screen up so you can see if it does land or not. When it does land, it will have that label already in place, and ACM will automatically deploy that application. So the application will automatically be pushed to that cluster. And that's the beauty of ACM, is it makes the control extremely simple and a singular point. Does that make sense, Graham?
Awesome. Thank you very much, Ian. That was really great. So let's get back to the game. I'm going to share my screen again. Pat, where's Pat? Pat, can you share the screen? Can you start the game again? I keep looking over there. Pat, I keep him in a box over there. Pat, can you start the game? Because we're going to go back to the game now. Let me see. You should be able to see the game on my screen now. So let's start playing. So you should rejoin the game. I'm going to rejoin the game with my bag. What's my bag? $95, $93.75. Let's go for that. Hey, there you go. I've got $355. Bald Roarer. Let's see if I'm on the leaderboard. No, Bald Roarer is not on the leaderboard. So Stumpbeard is still up there. Let me start guessing some more prices. So I've got a bum bag here, or a fanny pack if you're in the US. Let's say, what is it going to be worth? I reckon you're going to pay $25 for this. There's no $5, $23. No, $20? $29. Okay. $29 flat, I think. There we go, $29. Now we've got a beanie that's coming up. So let's look at the pieces of this game as you're playing. So your devices, as we've seen on that Mark was showing, your devices are connecting through to our central, our edge cluster. You've got edge devices connecting through to our edge cluster. That's where the game's connecting to, and it's pushing data backwards and forwards between that edge cluster. Now, when we go to the leaderboard, that data is being pushed through to the leaderboard, and the leaderboard is sitting in the admin cluster. So we're using ActiveMQ, and we're using AMQ from Red Hat AMQ, and the Kafka streams within there to push data across. Now, when we're pausing the game and some of the game data, that messaging is being pushed into our Red Hat data grid. And data grid is distributed across all of our clusters to make the cluster work from an application perspective. So that's our game. So hopefully you're on the game there. So if I go look at my leaderboard, let me just refresh my leaderboard. Okay, the leaderboard is not refreshing. That's okay. Oh, here it comes back. So Stumpbeard is still in the lead. Some brilliant names here. So we've got Rattle Ocelot, and we've got Fantasy Throat is still in there. Oh, come on, Fantasy Throat. You see if you can move up the leaderboard. Okay, we're almost out of time with our game. So normally when we do this live, then we're on stage, we get the leader up, and they can come up and claim a prize. Unfortunately, we're virtual, and it's across all of EMEA. So we're live across EMEA, and we don't have time to go across and give prizes out. So unfortunately, I'm going to stop the game there, though. So stop the game, Pat. So we're going to stop the game there, and we'll say game over. So that's the end of our demo. That's the end of our game. Hopefully you've get some prizes. Hopefully you've got on the leaderboard. It's been awesome. We've shown you some of the power of Advanced Cluster Manager. I'm going to stop my screen so you can see our lovely faces. You've seen the power of Advanced Cluster Manager. You've seen some of the application architecture pieces that has been awesome. That said, I'm just going to thank everyone that's involved in this demo. So thank you to the team that were presenting. Thank you to all of our backstage crew as well. So thank you to Erin. Thank you to Mark. Thank you to Ruth. Thank you to Pat Harrison and Pat Carey and Phil Prosser. And everyone else that's helped build this demo. So hopefully you've enjoyed it. Hope it's just been a bit of fun. We're going to be on a Q&A later on in the afternoon. So come and join us for that. So hope you all had fun, and hope you enjoy the rest of the day. So it's going to be awesome. There's lots of things to see. Thank you, everyone. Bye.